November 12, 1942, Richmond, California. Constructed cargo ship, 441 feet long and weighing 28,490 tons, was poised to slide into San Francisco Bay from the gates of Permanente Metals Corporation, Yard No. 2. The vessel had been assembled in just 4 days, 15 hours, and 29 minutes. In traditional shipyards, master craftsmen had spent 6 to 8 months building ships of comparable size, a process unchanged since the era of the American Revolution. Yet here stood a complete Liberty ship, ready for deployment. Over 1,000 workers stepped back from the hull of the SS Robert E. Perry, workers who were not seasoned shipwrights but former secretaries, farmers, homemakers, and laborers who had learned welding only weeks earlier. A crowd of officials, journalists, and rival shipyard executives had gathered to witness a moment that would spark a profound transformation in industrial manufacturing. This was the beginning of a systematic revolution in American production that would resonate for decades. The mathematics of Allied victory were being determined not on the battlefield, but in assembly statistics that challenged every prior assumption about shipbuilding limits, timelines, and industrial capability. The revolution had its roots on December 27, 1940, when Henry J. Kaiser signed his first shipbuilding contract. A man who had never built a ship nor run a shipyard, Kaiser had spent his career moving earth and pouring concrete for massive dam projects across the American West. Yet here stood the 58-year-old construction magnate, who had pledged to the United States Maritime Commission that he would deliver 30 cargo ships for the British government within 2 years. Veteran shipbuilders dismissed him as an idealistic novice. The Todd Bath Iron Works, one of the nation's oldest shipyards, reluctantly partnered with Kaiser, assuming their expertise would compensate for his lack of experience. What none anticipated was that Kaiser's unfamiliarity with traditional shipbuilding would prove his greatest advantage. Among the onlookers was William Francis Gibbs, America's most esteemed naval architect, whose firm Gibbs & Cox had designed the Liberty ships based on British models. Gibbs had designed more ships than Kaiser had ever seen, yet the transformation began in the planning offices of Todd Shipyards in New York. In early 1941, as Kaiser and his engineers studied conventional shipbuilding practices, they quickly realized these methods could never satisfy wartime demands. Kaiser's chief engineer, Clay Bedford, had recently visited a Ford Motor Company assembly line in Detroit, observing car chassis moving down the line as workers added prefabricated components at each station. Bedford returned to California convinced the same assembly line principles could be applied to shipbuilding. Traditional shipbuilders scoffed at the idea. The first real shock came when Kaiser proposed eliminating riveting entirely. Conventional ship construction relied on rivets, heated metal pins hammered through overlapping steel plates. Even the most skilled riveters could manage only about 100 rivets per day, and each Liberty ship required roughly 1 million rivets if built using traditional methods. Kaiser suggested using electric arc welding instead, a technique he had perfected constructing pipelines across the American West. Vice Admiral Emory Land, chairman of the United States Maritime Commission, examined Kaiser's proposal with deep skepticism. His private correspondence preserved in the National Archives revealed the maritime establishment's reaction. Welding has never been proven reliable for hull construction at this scale. The British Navy forbids welding on warship hulls. Kaiser is proposing we bet America's supply lines on an unproven technology. Yet land also recognized desperation. German U-boat and surface raiders were sinking Allied shipping faster than traditional shipyards could replace vessels. In 1941 alone, approximately 3.6 million tons of Allied shipping would go to the ocean floor from all causes. Literally starving. American shipyards using conventional methods would require an average of 230 days to build a single cargo ship. At that pace, the Allies would lose the Battle of the Atlantic before American industry could respond. The decision to approve Kaiser's contract represented not confidence, but necessity. The Richmond shipyard rose from empty mud flats between January and December 1941. Kaiser's construction crews, experienced in building dams and highways, erected a facility that horrified traditional maritime engineers. Instead of the massive gantry cranes and longitudinal building ways that characterized established shipyards, Richmond featured something entirely different. The yard was laid out like an automobile assembly plant. Open areas for prefabrication surrounded 7 parallel building ways. Railroad tracks crisscrossed the facility designed to move massive steel sections weighing up to 150 tons. Overhead cranes capable of lifting entire ship sections stood every 100 feet. John Riley, chief naval architect for Bethlehem Steel Corporation and a 30-year veteran of shipbuilding, visited the Richmond Yard in May 1941. His inspection report, marked confidential at the time, contained technical criticism and grudging admiration. "Kaiser has violated every principle of efficient shipyard layout I learned in 3 decades of experience. His prefabrication areas are too large. His crane capacity is absurdly excessive. His building ways are too short. Yet I must admit the facility is designed for exactly what he claims, rapid assembly of prefabricated sections." The arrival of workers provided the next phase of revolutionary change. Traditional shipyards recruited from established maritime communities where skills passed from father to son across generations. Kaiser advertised in newspapers across America, offering wages 20% above standard industrial rates and promising to train anyone willing to work. The first groups arrived in Richmond in August 1941. The simplification of complex tasks into repeated simple operations borrowed directly from assembly line manufacturing proved devastatingly effective. By October 1941, Kaiser employed over 10,000 workers in Richmond with fewer than 200 having any previous maritime experience. Traditional welders spent 4 years as apprentices learning comprehensive skills. Kaiser's instructors taught specific techniques for specific tasks in approximately 2 weeks. Workers didn't need to know how to weld everything, only how to weld the vertical seams on bulkheads or horizontal deck plates or curved hull sections, which they would do repeatedly. As workers gained experience through late 1941 and early 1942, something unexpected occurred. The construction time for Liberty ships began falling dramatically. Kaiser's first Liberty ship took 197 days to build and deliver. Ship number 2 required 169 days. Ship number 5 required 128 days. Ship number 10 required 97 days. By spring 1942, Richmond was completing Liberty ships in 70 days on average. Traditional shipyards watched with growing alarm as this untrained workforce achieved production speeds that matched their own highly skilled crews. The prefabrication approach that traditional builders had dismissed proved its power. Instead of building ships from keel to deck in sequence, Kaiser's yards fabricated entire sections simultaneously across the facility. While one crew assembled a bow section in the prefabrication area, other crews built stern sections, deckhouses, engine rooms, and bulkheads in parallel. When sections were complete, massive cranes lifted them onto the building ways where welding crews joined them together. Albert Wooding, production supervisor at Richmond Yard No. 2, explained the efficiency in a 1943 interview with Fortune magazine. "In traditional shipbuilding, you cannot install the engine until the engine room is built. You cannot build the engine room until the hull is complete. Everything happens in sequence." Kaiser's approach allows parallel production. While one crew welds hull plates, another crew assembles the engine in a separate area. When both are ready, we drop the completed engine into the completed engine room and weld it in place. Tasks that previously required weeks now take hours. The statistics of parallel production revealed manufacturing efficiency that seemed impossible to traditional builders. A conventional shipyard might have 50 workers attempting to install an engine over 3 weeks, working in the cramped confines of a partially complete engine room. Kaiser's prefabrication approach assigned 200 workers to assemble the complete engine and its mounting structure in an open workshop over 5 days, then used cranes to position the entire assembly in a single 8-hour operation. More disturbing still to traditional maritime authorities was the casual elimination of centuries-old shipbuilding practices. Ships had always been built from carefully drafted plans that specified every detail. Kaiser used simplified drawings that provided basic dimensions and left details to workers' judgment. Traditional builders considered this recklessness. Kaiser called it flexibility. Vice Admiral Howard Vickery, vice chairman of the Maritime Commission and a career naval officer, initially fought against Kaiser's simplified specifications. His transformation from skeptic to supporter documented in commission meeting minutes illustrated the power of results over theory. In January 1942, I opposed Kaiser's request to reduce drawing specifications. Ships are not automobiles. Maritime construction requires precision. But by March, Kaiser's yards were outproducing our traditional contractors by 40%. By June, the gap had widened to 70%. I learned that perfection is the enemy of sufficient. Kaiser's ships were not beautiful. They were adequate, and adequate ships delivered more cargo than perfect ships still under construction. As construction speeds increased through spring and summer 1942, competition developed among Kaiser's 7 shipyards spread across California, Oregon, and Washington. His son Edgar, who served as vice president and general manager, overseeing all Kaiser shipyards with particular focus on the 3 Pacific Northwest facilities, managed the Oregon Shipbuilding Corporation in Portland. Clay Bedford oversaw the Richmond yards in California. The two men, both driving and ambitious, began an informal contest to see whose facility could build ships faster. The race between Richmond and Portland became a public spectacle through fall 1942. Newspapers published updates like sports scores. Competition records fell repeatedly until Oregon Shipbuilding built the Joseph N. Teal in just 10 days in September 1942. Vice Admiral Vickery eventually ordered the speed competition stopped, declaring them stunt demonstrations that distracted from actual production goals. But the competition had served Kaiser's purpose. Workers across all 7 yards now believed that extraordinary speed was not merely possible, but expected. November 1942 brought the ultimate demonstration. Vice Admiral Land, visiting Richmond to inspect production, made an offhand comment to journalists that was overheard by Clay Bedford. The Admiral remarked that Liberty ship construction had improved remarkably, but noted that the recent speed records still palled compared to what mass production had achieved in other industries. Bedford took the comment as a challenge. He proposed to Vice Admiral Land that Richmond Yard No. 2 would attempt to build a complete Liberty ship from keel laying to launch in under 10 days, cutting the Joseph Neal's record in half. Land, skeptical but intrigued, authorized the attempt on condition it not disrupt regular production schedules. Bedford selected the 47th hull to be built at Yard No. 2 for the record attempt. The ship would be named SS Robert E. Peary after the Arctic explorer. Starting Sunday, November 8, at 1 minute past midnight, over 1,000 workers operating in carefully coordinated shifts would attempt something unprecedented in maritime history. The prefabrication strategy reached its ultimate expression during the pier construction. Every major component had been built, inspected, and staged before the keel touched the building way. The bow section, comprising more than 50 individual pieces, had been fully welded and equipped with anchor hardware, chain lockers, and forward crew quarters before assembly began. The stern section included the completed steering gear, propeller shaft, and aft crew spaces. For complete cargo holds, each one a massive rectangular structure of steel waited to be lifted into position. The engine, a 140-ton triple-expansion steam power plant built by Joshua Hendy Iron Works in Sunnyvale, had been mounted on its foundation structure and tested before leaving the factory. Where conventional shipyards built from Quito to deck over months, Kaiser's yards assembled a nearly complete ship from prefabricated sections in days. For days into construction, the hull was complete. Engine installed, deck houses positioned, cargo hold secured, steering gear mounted. On Thursday, November 12, at 3:30 p.m., just 4 days, 15 hours, and 29 minutes after the keel touched the building way, SS Robert E. Peary slid down the launching rails into San Francisco Bay. The ship was delivered for service on November 15, setting an additional record of 7 days, 14 hours, and 32 minutes from keel laying to full delivery. The crowd of observers included maritime officials, military officers, competing shipyard owners, and journalists from across America. Many arrived expecting to witness either failure or a compromised vessel that looked complete but lacked functionality. What they saw instead was a fully operational ship that required only minor fitting out before entering service. Vice Admiral Land, present for the launching, made brief remarks that were recorded by newsreel cameras. His words captured the maritime establishment's forced recognition that everything had changed. 6 months ago, I would have called this impossible. Traditional shipbuilding wisdom accumulated over 3,000 years said you cannot build a proper ship in 5 days. Henry Kaiser has made traditional wisdom obsolete. The United States Maritime Commission will now require all contracted shipyards to adopt these methods. The psychological impact on traditional shipbuilders was profound and immediate. The same yards that had dismissed Kaiser as an ignorant outsider just 18 months earlier now sent engineers to study his approaches. The president of New York Shipbuilding Corporation, one of America's oldest and most prestigious yards, visited Richmond in December 1942. His confidential report to his board of directors revealed complete ideological collapse regarding traditional approaches. Kaiser has achieved what our industry considered impossible by refusing to accept our limitations. He treated shipbuilding as a manufacturing problem rather than a craft tradition. He simplified where we sought perfection. He standardized where we customized. He trained masses of unskilled workers where we cultivated generational expertise. The result is ships built in 1/10 the time at 2/3 the cost. We must either adopt his approaches or accept irrelevance. By early 1943, Kaiser's influence had transformed American maritime production. 18 shipyards across the country were building Liberty ships using prefabrication and welding. Average construction time had fallen from 230 days initially to just 42 days by mid-1943. The United States was launching 3 Liberty ships daily, more tonnage than German submarines could sink. But perhaps the most devastating challenge to traditional maritime authority came from the quality of Kaiser's workforce. The tens of thousands of women, minorities, and untrained workers who had built these ships represented a direct reputation of the old guild system that had dominated shipbuilding for centuries. At peak production in 1944, Kaiser's 7 yards employed approximately 196,000 workers. Of these, over 40,000 were women, representing a remarkable percentage of female industrial workers. By mid-1944, women comprised 27% of Richmond's production workforce. The 3 Northwest Kaiser yards alone employed over 31,000 women by 1944. African American workers numbered in the tens of thousands, employed in skilled positions including welding, fitting, crane operation, and even supervisory roles. A level of workplace integration unusual for 1940s America. The democratization of skilled work that Kaiser enabled carried implications far beyond wartime production. By demonstrating that complex industrial production could be executed by trained laborers rather than relying on generational craftsmanship, Kaiser's shipyards challenged long-held assumptions about skill, labor, and organizational design. Christmas 1943 offered another vivid illustration of this transformed industrial culture. While conventional shipyards granted only 1 or 2 days off for the holiday, Kaiser's facilities maintained their production schedules, but instead of merely demanding labor, his organization celebrated workers' contributions. At the Richmond yards, management arranged festive Christmas meals in the cafeteria, featuring turkey, ham, and all the customary trimmings, served free to employees on shift. Local churches sent carolers, and the Richmond Municipal Band performed. Kaiser personally visited the yards, shaking hands and expressing gratitude directly to workers for their dedication. By mid-1944, Kaiser's 7 shipyards had constructed over 800 Liberty ships. Yet his methods influenced far beyond his own operations. All 18 U.S. shipyards producing Liberty ships had collectively completed 2,400 vessels by that time. Victory ships, a larger and faster model introduced in 1944, employed the same prefabrication and welding techniques. Between 1941 and 1945, U.S. maritime output surpassed 5,500 ships, totaling roughly 53 million tons of cargo carrying capacity, a scale staggering to contemporaries and still impressive today. Commander Joseph Kenworthy of the Royal Navy, assigned to the British delegation in Washington, documented the British view with awe and some envy. His declassified reports noted that the United States was constructing merchant vessels at a rate exceeding the combined capacity of the rest of the world. Kaiser alone produced more tonnage monthly than the entire British shipbuilding industry. The ships were crewed by traditional standards, unrefined in design, but functional, numerous, and fast to produce. While the Royal Navy relied on painstakingly crafted warships requiring years to complete, the Americans achieved adequate ships in weeks. Quantity multiplied by thousands overcame quality multiplied by dozens. Perhaps most remarkable was the post-war impact. Analysts had predicted the shipbuilding boom would collapse, leaving vast numbers of workers unemployed and facilities abandoned. This proved partially true. Liberty ship construction ended in September 1945, and by December, Kaiser's workforce had shrunk from 200,000 to under 20,000. Richmond yards that had once employed 100,000 stood mostly idle by spring 1946. Yet the knowledge gained during the wartime program endured. Prefabrication, welding, and parallel assembly techniques pioneered by Kaiser became standard practice globally. When Japan and South Korea rebuilt their maritime industries in the 1950s and 1960s, they studied Kaiser's Liberty ship program and adopted his methods as the cornerstone of their modern shipyards. The massive shipbuilding facilities in Ulan, South Korea, and Nagasaki, Japan, that would dominate world shipping construction for decades were direct descendants of Richmond Shipyard's revolutionary practices. John Bunker, professor of maritime history at the State University of New York Maritime College, summarized Kaiser's lasting influence in his definitive study published in 1972. Kaiser entered shipbuilding as an outsider, ignorant of maritime tradition, unconstrained by conventional wisdom and willing to apply manufacturing principles that the established industry considered inappropriate for ship construction. In 36 months, he built more ships than had been constructed in America during the entire previous century. More importantly, he fundamentally altered how ships would be built worldwide for the remainder of the 20th century. The modular construction, prefabrication, and welded assembly that Kaiser pioneered are now universal standards. Every modern shipyard, whether building container vessels in Korea, oil tankers in Japan, or cruise ships in Europe, uses approaches derived from Kaiser's Liberty ship program. The magnitude of Kaiser's achievement can be measured in statistics that reveal both the scale of the program and its remarkable success. Production statistics show 2,710 Liberty ships built across 18 American yards between 1941 and 1945, an average of 1.8 ships per day at peak production. Kaiser's 7 yards alone produced 1,490 ships, comprising 27% of total American wartime merchant shipping built under maritime commission contracts. Construction time fell from an average of 230 days for the first Liberty ships in 1941 to 42 days by 1943, with the record holder Robert E. Perry requiring just 4 days and 15 hours from Cologne to launch. Labor efficiency improved dramatically as workers gained experience. The first Liberty ships required approximately 1.1 million worker hours to complete. By 1943, average worker hours had fallen to approximately 486,000 per ship. Kaiser's most efficient yards, Richmond numbers 2 and 3, achieved construction in as few as 350,000 worker hours by utilizing 3-shift 24-hour production schedules and maximizing prefabrication. Cost efficiency matched schedule improvements. The first Liberty ships cost approximately $1.75 to $2.0 million each. By 1943, costs had fallen to $1.8 million despite rising wages and material prices, reflecting improved efficiency and learning curve effects. Each Liberty ship displaced 14,245 tons fully loaded and could carry 10,800 tons of cargo. The vessels could transport 2,840 jeeps, 440 tanks, or 230 million rounds of ammunition in a single voyage. Powered by triple expansion steam engines that were deliberately old-fashioned but reliable and easy to manufacture, the ships achieved speeds of 11 knots, adequate for convoy operations. Training efficiency proved equally remarkable. Kaiser's schools train workers in specific tasks in an average of 2 weeks. The fastest training produced productive spot welders in just 10 days. More complex positions like crane operators or ship fitters required 4 to 6 weeks of training. This compared to traditional maritime apprenticeships lasting 4 years for basic competency and 10 years for master craftsman status. The key difference was specialization versus comprehensive training. Traditional apprentices learned all aspects of shipbuilding. Kaiser's workers mastered specific repeatable tasks that they would perform hundreds of times. The battle casualty rates among Liberty ships demonstrated their effectiveness despite skepticism about rapid construction approaches. Of 2,710 Liberty ships built, approximately 200 were lost to enemy action, a loss rate of 7.4%. This compared favorably with pre-war merchant shipping loss rates and proved that welded construction, while initially suspect, produced seaworthy vessels. Some ships experienced structural failures due to welding defects. 3 Liberty ships broke completely in half due to brittle fracture problems, representing 0.11% of production. Nearly 1,500 instances of significant brittle fractures occurred across the Liberty fleet, but catastrophic complete breaks were rare. These failures led to improved welding procedures and steel specifications that eliminated the problem by 1944. Longevity statistics provided the ultimate vindication of Kaiser's construction approaches. Liberty ships designed as emergency vessels with expected service lives of 5 years proved remarkably durable. Many remained in service for decades after the war. The SS John W. Brown, built in 1942, remains operational as a museum ship in Baltimore as of 2024, 82 years after construction. The SS Jeremiah O'Brien, also built in 1942, is preserved in San Francisco and participated in the 50th anniversary commemoration of D-Day in 1994, actually sailing to Normandy under its own power after 50 years of existence. A third Liberty ship, SS Helles Liberty, serves as a static museum ship in Greece. Post-war careers of Liberty ships extended far beyond their design lifespan. Of the approximately 2,510 Liberty ships that survived the war, approximately 835 remained in commercial service through the 1960s. Many were sold to foreign shipping companies where they operated into the 1970s. The SS Albert Bow, the last Liberty ship built and delivered on October 30, 1945, was not scrapped, but converted. Sold in 1964 for $65,557, it became the fish cannery ship Star of Kodiak in 1965 and remains today as the landlocked headquarters of Trident Seafoods in Kodiak, Alaska. Still in existence 8 decades after construction. The economic impact of the Liberty ship program extended across American industry. The massive steel requirements drove expansion of steel production capacity, particularly on the West Coast, where Kaiser built the Fontana Steel Mill specifically to supply his shipyards. This mill, completed in 1942, 5 months ahead of schedule, produced approximately 700,000 tons of steel annually and established California as a major steel-producing region for the first time. The magnesium required for incendiary bombs and aluminum for aircraft were produced in Kaiser plants built to support the integrated war production effort. Employment effects rippled through communities across California, Oregon, and Washington. The city of Richmond, California, grew from a population of 23,000 in 1940 to over 100,000 by 1943. Driven entirely by shipyard employment, Kaiser built Vanport City in Oregon, which briefly became the state's second-largest city with a population exceeding 40,000, all of whom worked in shipyards or supporting industries. These boom towns, while temporary, demonstrated the transformative effect of concentrated industrial investment. Healthcare innovation emerged as an unexpected legacy of Kaiser's shipbuilding program. To provide medical care for his massive workforce, Kaiser partnered with physician Sidney Garfield to establish prepaid healthcare programs that eventually evolved into Kaiser Permanente, one of America's largest health maintenance organizations. The model of prepaid preventive healthcare pioneered in the shipyards influenced American medical practice for decades and served over 12 million members by the early 21st century. The workers themselves carried forward the lessons of the wartime experience into decades of PCM achievement. The shipyards gave thousands of young people, especially women and minorities, opportunities to develop capabilities they would never have access through conventional career paths. Those opportunities opened doors that stayed open for the rest of their lives. The technological innovations developed during the Liberty ship program influenced industries far beyond maritime construction. The welding techniques refined under wartime pressure became standard in structural steel construction, petroleum refining equipment fabrication, and pressure vessel manufacturing. The prefabrication approaches pioneered at Richmond influenced construction practices in housing, bridge building, and industrial facilities. The organizational principles of parallel production, simplified specifications, and rapid worker training became foundational concepts in operations management and industrial engineering education. Professor Michael Porter at Harvard Business School analyzing American industrial competitiveness in a 1985 study identified the Liberty ship program as a crucial case study in rapid capability development. Kaiser demonstrated that industrial capacity is not fixed but can be created quickly when necessity demands it. The United States entered World War II with minimal merchant shipbuilding capability. Within 24 months, American yards were producing more tonnage than the rest of the world combined. This proved that industrial infrastructure, workforce skills, and production systems could all be developed at unprecedented speed when properly organized. That lesson has relevance beyond wartime emergency. It suggests the perceived limitations on industrial capacity often reflect organizational and conceptual constraints rather than physical impossibilities. The psychological transformation that the Liberty ship program created among industrial managers and engineers proved as significant as the physical ships produced. Before Kaiser, manufacturing executives accepted conventional wisdom about production limits, skill requirements, and organizational structures. Kaiser demonstrated that conventional wisdom could be wrong and that breakthrough performance required questioning fundamental assumptions. The Liberty ship story ultimately stands as testament to a profound truth about human capability and industrial possibility. The ships themselves, while crucial to Allied victory, mattered less than what their construction proved. Ordinary people, given training and opportunity, could achieve extraordinary results. Complex products previously requiring years of craft tradition could be manufactured in weeks using systematized processes. Industries resistant to change for centuries could be revolutionized in months when necessity and innovation combined. Admiral Chester Nimitz, commander of the Pacific Fleet, reflected on the strategic impact of American maritime production in his post-war memoir published in 1960. "We fought across 5,000 miles of Pacific Ocean, supplied by ships built faster than the enemy could sink them." Japan's military planners assumed American industrial capacity was impressive but finite. They believed that if they sank enough ships, eventually American logistics would collapse and we would be forced to negotiate. They failed to account for Henry Kaiser. By 1944, we were replacing shipping losses faster than they could inflict them. The mathematics of attrition favored the side that could build 3 ships daily over the side that could sink 2 ships daily. Industrial capacity, not martial valor, determined the outcome. The Pacific War was won in the shipyards of Richmond, Portland, and Baltimore, as much as on the beaches of Iwo and Okinawa. In the end, Kaiser's greatest achievement was not the 1,490 ships his yards produced, but the transformation of what industries believed possible. The WWII, completed in under 5 days, stood as undeniable evidence that established practices were not infallible, that conventional assumptions could be challenged, and that groundbreaking progress demanded bold, unconventional methods. The maritime experts who had dismissed Kaiser as an inexperienced outsider in 1940 spent the years after 1945 studying and adopting his innovations. The young workers who learned to weld, assemble, and fabricate under wartime pressure carried those skills and the confidence they gained into post-war careers that helped rebuild America's economy. Techniques developed under emergency conditions became standard practices, influencing manufacturing across industries worldwide. The story of how one civilian's methods enabled Liberty ships to be constructed in days rather than months is ultimately a story of transformation through action. It demonstrates that the most significant revolutions often come from those unbound by tradition, that progress requires challenging accepted limits, and that human potential surpasses conventional expectations when effectively organized and inspired. Kaiser's workforce were ordinary individuals, yet they achieved extraordinary results because someone believed in them and created systems that allowed their success. This lesson, proven in Richmond's shipyards and validated by 2,710 completed vessels, remains relevant wherever industries face challenges deemed impossible by conventional wisdom. Though most Liberty ships have long since been scrapped or rest beneath the waves, the revolution they represented lives on in modern shipyards, in factories that use prefabrication, in rapid skill training programs, and in every manager who asks whether impossible truly means impossible or merely untried. Henry Kaiser's legacy is etched not just in steel, but in a transformed understanding of what committed people can achieve when freed from tradition and encouraged to attempt what experts claimed could not be done. From signing his first contract in December 1940, knowing nothing of shipbuilding, to the launch of the WWII in less than 5 days in November 1942, and through the delivery of the last Liberty ship in September 1945, Kaiser proved that industrial revolutions arise not from incremental tweaks, but from fundamentally rethinking what is possible. The 2,710 Liberty ships produced between 1941 and 1945 carried more than cargo, they carried proof that human ingenuity, unshackled from tradition and driven by necessity, can achieve the seemingly impossible.